Problem number 1 from the Chapter 6 review. The integral from 0 to 3 of secant squared theta d theta. So to integrate this, we're not going to need any kind of special u-subs or anything like that. All we're going to need to do is just take the integral. So we know the integral of secant squared is simply just tangent. And so we get the integral is tangent theta from 0 to pi over 3. So now you plug in your a and b limits and we get tangent of pi over 3 minus tangent of 0. And tangent of pi over 3 is the square root of 3 minus tangent of 0 is 0. So you get the square root of 3. Alright, problem number 2. The integral from 1 to 2 of x plus 1 over x squared dx. So this is another one that you don't need a u-sub for. We're just going to take the integral separately. But before I do that, I'm going to rewrite the integral as the integral from 1 to 2 of x plus x to the negative 2 dx. And this is going to allow me to integrate a little easier. So here when I integrate, I get x squared over 2 plus x to the negative 1 divided by negative 1 from 1 to 2. So this becomes x squared over 2 minus 1 over x from 1 to 2. So this is 4 over 2 minus 1/2 minus 1 squared over 2 minus 1 over 1. So this is 4 over 2 minus 1/2 minus 1/2 minus 2/2. So I get 3/2 minus a negative 1/2, which gives me 4 over 2, which is equal to 2. Moving on to number 3. We get the integral from 0 to 1 of 36 divided by 2x plus 1 cubed. So for this one, we're going to need a u-sub, and we're going to let u equal to x plus 1. So du is going to be 2 dx. But what I want is a 36 dx. So I'm going to multiply both sides by 18. So 18 du is equal to 36 dx. And then we have to change our limits. So if x is equal to 0, then u is going to be equal to 2 times 0 plus 1. So u is equal to 1. If x is equal to 1, then u is equal to 2 times 1 plus 1, which is equal to 3. So our new integral becomes 1 to 3, 18, 1 over u cubed du. So this is 18 times the integral of u to the negative 3 du. So I get 18, and then when I integrate that, I'm going to get u to the negative 2 divided by negative 2 from 1 to 3. I get negative 9 times 1 over u squared from 1 to 3. So this becomes negative 9 times 1/9 minus 1 over 1. So negative 9 times 1/9 minus 9 over 9. Negative 9 times negative 8/9, and you get your answer is 8. Moving on to number 4, we get the integral from negative 1 to 1 of 2x times sine of 1 minus x squared dx. We're going to need another u-sub here, so I'm going to let u equal 1 minus x squared. So du is going to be equal to negative 2x. I don't want the negative, so then I go negative du is equal to x dx, 2x dx. So now I need to change my limits. If x is equal to negative 1, we get that u is equal to 1 minus negative 1 squared. So u is equal to 0. If x is equal to 1, we get u is equal to 1 minus 1 squared. So u is also equal to 0. So if we rewrite this integral, it'll be from 0 to 0 of negative sine of u du, and since the limits are the same, our answer is just 0. Moving on to number 5. This is the integral from 0 to pi over 2 of 5 of sine to the 3 halves x times cosine x dx. So we're definitely going to need a u sub here. So we're going to let u equal sine of x. So then du is equal to cosine of x dx. If x is equal to 0, then u is equal to sine of 0, which is 0. If x is equal to pi over 2, then u is equal to sine of pi over 2, which is 1. So then this becomes the integral from 0 to 1. Put the 5 on the outside, and I get u to the 3 halves du. So when you integrate, you get 5 times 3 halves plus 1 is 5 halves. So multiply that by 2/5 from 0 to 1. So these are going to cancel, and I get 2 u to the 5 halves from 0 to 1. So this gives me 2 1 to the 5 halves minus 0 to the 5 halves. And so I just get 2. Alright, number 6. So there's a couple ways to do this problem. The easiest way I found to do it is to actually just split up the integral. So this is going to be the integral of from 1/2 to 4 of x squared over x plus 3x over x dx. So this becomes the integral from 1/2 to 4 of x plus 3. And so when you integrate that, you're going to get x squared over 2 plus 3x from 1/2 to 4. So when you plug that in, you're going to get 4 squared over 2 plus 3 times 4 minus 1/2 squared over 2 plus 3 times 1/2. So 16 over 2 plus 12 minus 1/2 squared is 1/4 divided by 2 plus 3 halves. This is going to give me 8 plus 12 minus 1/8 plus 3 halves. So this is 20 minus 1/8 plus 12/8. So this is 160 over 8 minus 13 over 8. And that gives you 147 over 8. Alright, moving on to number 7. The integral from 0 to pi over 4 of e to the power of tangent of x times secant squared of x dx. So here we're going to let our u sub equal tangent of x. And du is going to be secant squared x dx. So we have to change our limits. If x is equal to 0, then u is equal to tangent of 0, which is just 0. And if x is equal to pi over 4, then u is equal to tangent of pi over 4, so u is equal to 1. And so now we get the integral from 0 to 1 of e to the u du, which is going to give us the integral of e to the u is just e to the u from 0 to 1. So you get e to the 1 minus e to the 0. So your answer becomes e minus 1. Number 8. The integral from 1 to e of the square root of ln of r over r dr. So we're going to let u equal ln of r. So then du is equal to 1 over r dr. And then changing our limits, if r is equal to 1, then u is equal to ln of 1, which is 0. If r is equal to e, then u is equal to ln of e, which is equal to 1. So we get the integral from 0 to 1 of the square root of u du. So this gives us the integral from 0 to 1 of u to the 1/2 du. This is going to give us u to the 3/2 times 2/3 from 0 to 1. So 2/3 times 1 to the 3/2 minus 0 to the 3/2. And so the answer is just 2/3.